Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. It begins long before sunrise. The air shifts softly outside your window, stirring without sound. Somewhere over the hills, a high cloud unfurls like a breath exhaled. The trees do not wake, but their branches sway gently as if in conversation with the passing wind. Far above, layers of invisible air move in different directions, some rushing west, others floating east, tangled in a dance you cannot see. And though your eyes are closed, the sky remains awake. The atmosphere is not a still sheet. It is a living body, vast, pulsing, restless. It stretches from the ground beneath your feet to the outer edges of space. A skin of motion that wraps around the earth. Within it, clouds form, moisture rises, heat escapes, and invisible waves of energy whisper across countenance. Even in sleep, it breathes. Each second, millions of molecules bounce and tumble. Heat drifts upward from roofs and oceans. Tiny droplets condense or vanish. Air pressure dips or lifts, gently massaging the weather forward and above. It all, satellites circle the globe like quiet sentinels, watching the ever-changing face of the sky. Weather never stops. It does not wait for morning. It does not pause for dreams. And so, machines keep watch. They do not blink. They do not tire. They absorb data from every direction. Barometric readings, cloud formations, radar signals, wave heights, jet stream, velocities. Each bit of information, once fleeting and forgotten, is now caught and kept, stored, cataloged, and woven into a living picture. These are not the machines of storybooks or steel. They are mathematical minds made of code and pattern, soft intelligence trained to listen to the sky. We call them models. But they are more than that. They are quiet dreamers of the possible. A weather model is like a mind spread across the world. It ingests the present, the pressure over Paris, the humidity in Havana, the temperature on a Tokyo rooftop, and lets it settle like ink in water. Then, using physics, memory, and mathematics, K begins to stir. It imagines forward, not just one future, but many. One where the rain turns east, one where the clouds climb higher, one where the storm never forms, one where it does. These simulations unfold in parallel, guided by rules older than any machine, Newton's laws, thermodynamics, the truths of moisture and heat. And yet, like a storyteller, the machine must choose which tale feels most true. It does this by learning from the past. Thousands of storms, millions of mornings, cold fronts, heat domes, monsoons, droughts, each stored like pages in a diary. The machine reads these entries over and over, finding echoes between yesterday's thunder and today's rising air. It learns how clouds behave in spring versus fall. It notices how the sea cools differently near icebergs than near coral reefs. It pays attention to the strange patterns that humans might overlook, how a desert breathes at night, how a forest sweats at dawn. It listens to things we can't hear, and slowly it grows confident in its whispers. This is not the same as certainty. Weather, like life, resists perfection. A butterfly really can bend the wind with a wing beat because the atmosphere is sensitive, chaotic, and exquisitely complex. But AI does not need to know everything. It only needs to learn enough to say, something is coming. A shift in the sky, a turn in the wind, a quiet thickening of the air that means snow by sunrise or fog by noon. Enough to give warning, not with panic, but with presence. And so, while you sleep, the machine dreams. It watches satellite footage, not as a human sees it, but as patterns of brightness and motion. It recognizes the telltale swirl of a cyclone just forming hundreds of miles away. 8. Traces the spine of a storm front from coast to coast. 8. Notices the blooming of a heat wave, slow and steady, like fire beneath glass, all while you lie still. Outside your window, nothing looks urgent. The clouds drift like lace across the stars, but far above them, the models are humming, running their calculations, weighing their probabilities, watching the sky as if it were a language to be translated, not from words, but from temperature and motion, because that's what forecasting is. Not prophecy, not prediction like fortune-telling, but translation from the breath of the earth into something understandable. In ancient times, we read the clouds with our eyes and bones. A red sunrise, a ring around the moon, a sudden ache in the knees. These signs, passed down in stories, worked surprisingly well, because weather is not random. It follows laws, moves with rhythm, and now, I watches with new eyes. It sees not just the ring around the moon, but the moisture content of the upper atmosphere. Not just the wind in the trees, but the direction of the jet stream above them. Not just the darkening sky, but the precise angle of light filtered through cirrus clouds. It is like giving intuition a telescope, like handing the old weather watcher a map drawn in numbers. Yet, the machine doesn't forget where it came from. It still depends on data, human data, collected with instruments built by hands. It still listens to weather balloons, satellite feeds, ground stations. It is still tethered to Earth, but in its silence, it can process what we cannot. Billions of numbers revised each hour, and with that silence comes clarity. The AI doesn't worry. It doesn't guess. It simply calculates what is probable. And it does so again and again, every hour. Every update, refining its view like sharpening a pencil until a picture emerges. A likely tomorrow, and when you rise, groggy and slow, you glance at your phone. 70% chance of rain. It's breezy afternoon, cooler by night. Few numbers, a sentence. You trust it more than you realize. But that sentence is the final ripple of a vast ocean. A whisper from the sky. It's translated by a machine, delivered to your pocket. You didn't feel the low pressure trough deepening over the mountains. You didn't notice the shift in wind direction 3 hours before dawn. But the model did. It carried those signals forward, like small clues in a mystery. And now you carry an umbrella, or wear lighter clothes, or change your plans. This is the gift of machine learning and meteorology. Not perfection, but preparedness, because weather will always surprise us. Storms will always bend around logic. But each year, each model, each forecast brings us closer to understanding the sky's language. And slowly, the distance between question and answer shrinks. What will tomorrow bring? Not certainty, but confidence. Not magic, but science, wrapped in code. Not silence, but a deeper kind of listening. One that happens while you dream. Because even when your eyes are closed, sky remains in motion. And even when your mind drifts, the machine keeps watch, not as a master, but as a student, as a listener, a translator of wind and warmth. It listens for patterns in the chaos. It listens for shape in the shifting. And so, tomorrow's forecast begins not at sunrise, but now, in the dark, in the quiet, in the hum of a server learning how clouds move. Because somewhere above you, there is already changing. And somewhere inside a machine, the change is being understood. You lie quietly now, tucked under the soft stillness of your room. But above you, beyond the ceiling and the walls, the sky continues to move. It never truly sleeps. The clouds shift with quiet breath. The temperature slides a little cooler. Somewhere far away, pressure begins to fall. And just as it always has, the atmosphere begins to write its next sentence. Once, long ago, humans tried to read that sentence with their bodies. They looked for omens in the hush before a storm, felt it in the ache of knees, the sting of old scars. Farmers bent down and smelled the soil. Sailors watched for halos around the moon. Wind direction mattered. Bird flight mattered. The color of the sky at dusk held meaning. These weren't just superstitions. They were patterns, learned slowly, remembered carefully. The first weather tools were not machines. They were bones, skin, eyes, memory. A barometer came later, made of mercury and glass, rising and falling with the air's invisible weight. It was a wonder of its time, a way to hold the sky in a single number. You could watch the needle dip and know that rain was on the way. The anemometer followed cups spinning in the wind, measuring its speed without chasing it. Thermometers, hygrometers, radio sounds launched into the air by balloon. These instruments changed everything, turned weather into data. But still, the forecasts were made by people. Observers scribbled down numbers on notepads and compared them to past records. They knew that a certain pressure pattern seen over Paris might mean a cold front for Berlin by morning. They made maps, drew arrows, listened to the shape of the sky through ink and paper. It worked well enough, but not perfectly. The atmosphere is not a simple thing. It's chaos, layered on memory, layered on motion. Small changes ripple into large effects. One misplaced cloud can mean the difference between sunshine and storm. So forecasters kept watching and watching and waiting, and then something new arrived, a kind of machine that could learn. Artificial intelligence, or AI, isn't magic. It doesn't think like a human. It doesn't dream, but it can remember faster, deeper, and broader than we ever could. It begins not with intuition, but with data. Millions of points, temperature, wind speed, cloud height, sea surface warmth, from stations on land, buoys at sea, sensors on airplanes, eyes in orbit. All these numbers are fed into a model, a kind of digital brain made of code, designed to recognize relationships. At first, the models were simple, equations stacked like blocks. Then came more powerful algorithms, decision trees, regression maps, feedback loops, and the neural nets arrived. A neural net is a kind of artificial mimicry of your own mind. It has layers, connections, weights. It doesn't know what it's seeing, not at first, but it learns by seeing again and again. It's shown thousands of weather maps with the outcome labeled beneath: storm, sun, snow, drought, and over time, it starts to recognize which patterns lead where, not with certainty, but with confidence. It begins to say things like, when this shape appears here, and that one there, there's an 84% chance of rain by morning. It cannot tell you why, but it's often right. The process is called machine learning. And in weather forecasting, it's changing the game. Today's AI systems can crunch more data than any human team ever could. They watch global flows, not just local signs. They remember how similar storms behaved years ago. Even if you've forgotten, they find subtle cues that lie buried in the noise patterns, too complex for the naked eye, or even the trained forecaster. But here's what's remarkable. They don't replace humans, they amplify them. Meteorologists today are part scientist, part interpreter, part artist. They use AI as a lens, not a replacement. They ask the machine, what do you see? And then, using their own experience and understanding, they decide how to share that insight with the world. It is not unlike how a painter uses a brush, or how your own mind uses dreams. The code hums quietly, running forecasts through time, spinning possibilities. But still, someone must choose which story to tell, which outcome to emphasize, which risk to highlight, which signal to trust. Forecasting is still a form of storytelling. It always has been, and stories require humans. Now, the parameters are digital. The maps are alive. The predictions are no longer drawn by hand and rendered in real time across thousands of variables. Yet the soul of it is unchanged. It is still a search for meaning in the sky. Still a question asked before sleep. What will the weather be tomorrow? Ain't the answer? Like all good answers, it's never quite finished. AI brings something else, too. A kind of quiet revolution, because it doesn't need to guess. It just needs to listen. Listen to patterns in the wind, the waves, the data itself, and listening, over time, becomes knowing already. AI models like DeepMind's GraphCast and NVIDIA's Forecastanet can outperform some traditional models, not by a little, but by a lot. They make predictions faster, using less computational power, and sometimes with greater accuracy. These models don't try to simulate the physics of every particle in the atmosphere. They simulate the patterns themselves, the relationships between things. They are students of structure, and they learn not through equations, but through experience. Imagine a painter who has studied every sunset ever painted. They may not know the chemistry of clouds, but they know how the light bends. They know what comes next. That is what these AI models are becoming, weather pattern poets, trained on the memory of Earth, and they never sleep. There is something soothing in that, isn't there? That while you rest, the machines are still learning, still watching the skies, still listening for that subtle shift, the signal before the storm, silence before the snow. It means tomorrow's forecast may arrive before you open your eyes, delivered by a machine that never forgets what rain looked like 1,000 days ago. But the real beauty is this: you are still part of it. Because while AI learns from the past, it still relies on the present, on the data we give it, the questions we ask, the trust we offer. And sometimes, even now, a human will notice something the model missed. A pattern half-formed, a gust out of place, hunch that doesn't fit the output. Because intuition isn't obsolete. It's evolving. And in that evolution, something beautiful is happening. The barometer and the neural net now work side by side. One remembers how the sky felt. The other remembers how it behaved. Together, they form a picture more complete than either could see alone. So, you breathe in and let the machines take the night shift. Somewhere, an algorithm watches a storm swirl off the coast. Somewhere, a model recalibrates for morning. And somewhere, a human forecaster adjusts the forecast just slightly because they've seen this before. And they remember what came next, what will come next. Perhaps the machines will see it before we do, or perhaps deep in your own memory, in the space between instinct and thought, you already know. You hold the forecast in your hand, or maybe it hums from your phone screen, quietly in a glowing square. A percentage, a temperature, a symbol, a sun behind a cloud, a line of blue drops, the suggestion of wind, and yet, behind that gentle image lies a vast machine, a quiet process unfolding across satellites and servers, mathematics, and memory. You are looking at the surface of a deep, unseen structure, the anatomy of a prediction. Let's sink into it. The prediction begins not in the future, but in the now. Before anything can be forecast, the present must be captured. And this is no small task. The atmosphere is vast. It flows without edges. At every moment, it contains temperature, humidity, wind direction, cloud cover, sea surface pressure, and more. All of it shifting to model what's coming. You must know where. Everything is now. So the first step is data collection. Sensors on weather balloons rise through the layers of the sky, measuring pressure and moisture. Satellites gaze down from orbit, scanning cloud formations and thermal patterns. Airplanes whisper back wind speeds as they travel, while buoys bob. In the oceans, feeling the heartbeat of the sea. Ground stations, millions of them, watch from mountaintops, valleys, and city rooftops. Each one sends in its observation. Each one helps paint a picture. And when that portrait of the present is detailed enough, the next stage begins. This is where the machine wakes up. It receives the now, a snapshot of Earth's skin, its breath, its motion, and then it asks a simple question. What has the world done before in situations like this? The AI model is not dreaming, just remembering. Not like a person remembers a birthday or a voice, but in layers, in numbers, in weightings. Every storm, every drought, every sunny stretch and bitter freeze, these have all been seen before, and their patterns, their fingerprints, are stored in this system. The model compares, matches, weighs the moment. It says, when the sky looked like this, this is what followed. But weather is not a simple replay. No moment is exactly like any other. So prediction is not replication. It is suggestion. AI makes thousands of small choices. It nudges the data forward, step by step, using mathematical rules called differential equations. It runs the model ahead, 1 hour, 2, 10, 48. It watches the data unfurl, but it doesn't just run it once. It runs it again and again. Each time, it tweaks a small variable, adds uncertainty, cause no sensor is perfect, no cloud is precisely defined. So the AI builds an ensemble, a collection of possible futures, each slightly different. Some outcomes show rain, others don't. Some show strong wind, others suggest calm. The model does not choose just one, okay? It steps back, looks at the whole, and says, of all the futures I've seen, 80% contain a storm. That number becomes your forecast. That's where your 80% chance of rain comes from. Not from a bold statement, but from a careful stacking of outcomes. It is probability, built from memory. It is confidence, not certainty. And that is a beautiful thing, because the atmosphere is not a machine. It is not predictable in the way clocks are. It is living motion, chaotic, rich, responsive. And so, our models, our digital minds, must be humble. They must suggest, not proclaim. This humility is built into modern forecasts. A good prediction carries its uncertainty openly, gives you ranges, temperatures might fall between 12 and 15 degrees. Rain is likely, but not guaranteed. Storms are possible, with certain indicators pointing toward them. And this openness is power, because it lets you plan. It's not just react. You learn to interpret the language of probability, to feel the difference between mostly cloudy and a 60% chance of showers. You tune into the tone of the prediction, not just the text, and slowly, prediction becomes a conversation between you and the world, between memory and possibility, between machine and meaning behind the forecast. There's another layer, calibration. This is where the AI learns from its own past mistakes. If it predicts rain too often and the skies stay dry, it adjusts. If it misses early signs of fog, it retrains its attention. Every prediction becomes feedback. The model improves, not by magic, but by humility. Tate learns by watching itself. In this way, AI doesn't just predict weather, it also predicts itself, forecasting, okay? How well it will forecast. And this recursive learning is essential, because the world is changing. The patterns are shifting. Climate is not a fixed stage. Actors have begun to improvise, so our models must adapt. And AI, more than any fixed equation, has the flexibility to do so. It can sense when historical patterns no longer apply. It can weight newer data more heavily. It can question what it once trusted. This adaptability is why AI forecasting is now used everywhere. Aviation, agriculture, shipping, emergency response, even in your pocket. The weather app on your phone is likely powered by some form of machine learning. Its icons are simple, but its brain is vast, and yet, always, the forecast remains a whisper. Okay, gentle leaning toward what may come. A signal, not a command. So, when you read the weather tomorrow, when you see that small chance of rain or that wide swing in temperature, know that it comes not from arrogance, but from layers of learning. Know that behind it are satellites, sensors, servers, and an AI model that has watched the world turn 1,000,000 times before. And behind that model, still, are people, meteorologists who check its work, who decide when to trust, when to doubt, when to warn. Prediction is a chain of data, code, and human judgment, right? And every link matters. You are part of that chain too. Every time you carry an umbrella, just in case. Every time you look at the sky and say, they were right, or they were close. You are engaging in the ancient act of interpretation. The forecast is a signal. You complete the meaning. So rest tonight, knowing the process continues. The data flows, the models run, the atmosphere breathes, and somewhere in a quiet room lit by screens, a forecaster adjusts the narrative slightly, adds a note of caution, a shade of blue to the map, a few extra words of care, because prediction is not just science. It is service, and tomorrow's weather, though not promised, will arrive. Perhaps as expected, perhaps not, but always preceded by a forecast that tried to understand it. And in that effort, in that reaching toward what cannot yet be touched, there is something deeply human. Even when the reaching is done by machines, before a forecast can begin, before the algorithms hum or the models unfold, the machine must eat, not food, of course, but information. And not just numbers, but texture, color, shape. Direction. Prediction is not a guess. It is a story built on the bones of observation. And for AI to tell that story, well, it must be fed constantly, carefully, globally. So let's step into this quiet ritual, the feeding of the machine. Imagine a circle around the Earth, high above your head. Now fill that circle with satellites. They drift through the upper atmosphere, silent watchers, orbiting in patterns we designed. Some move in sync with the Earth's spin, always facing the same hemisphere. Others race from pole to pole, slicing the planet into vertical ribbons of observation. Each one watches something different. Some capture clouds in visible light, white curls over oceans, gray smudges over cities, the sea in infrared, sensing heat where human eyes see nothing at all. Still others measure microwave radiation, peering through thick storms to understand rainfall deep within. From above, they send down images, not just pictures, but multi-layered maps. Each pixel is data. Each swirl of cloud becomes an equation, and every hour, thousands of these images pour into forecasting centers. They are sorted, labeled, time-stamped. Then they are offered to the machine. But the sky is not just seen from above, down on Earth. Hundreds of thousands of sensors wake and blink, measure and transmit. In deserts, anemometers spin lazily, tracing the wind's speed. In rainforests, hygrometers feel the moist breath of the canopy. In cities, small stations tucked onto rooftops record the heat rising from concrete. Some sensors are buried deep in soil, where temperature changes slowly. Some are held aloft by balloons, which rise through layers of atmosphere, sending whispers as they go. Weather balloons, they may sound quaint, but they are essential. Twice a day, across hundreds of sites worldwide, these balloons are released. Each one carries a small package called a radio sonde. It rises gently through the sky, and as it goes, it measures air pressure, temperature, humidity, altitude, wind speed. These numbers are sent down in real time. When the balloon bursts, as it always does, high in the stratosphere, its job is done. And the data remains all of the satellites, sensors, balloons, feeds into a vast system. And the system is always hungry because the weather never stops. So the observations cannot either. There are buoys in the ocean, popping machines, floating in remote corners of the sea. They measure sea surface temperature, wave, height, wind, direction. Some are anchored to the seafloor. Others drift with currents. They form a net, not one you can see, but one you can trust. The oceans, after all, drive the weather. Warm water fuels storms. Cold currents steer air. The boundary between ocean and sky is thin, and it's alive. So the buoys report, the satellites scan, the balloons climb, okay? And somewhere, in rooms filled with soft blue light, this information arrives. The data is raw, messy, overlapping, filled with gaps. So meteorologists begin to clean. They filter out errors, calibrate mismatched instruments, align timelines, remove duplicate entries. It's like tuning an orchestra before a performance. The data must harmonize because the AI needs clarity. Once clean, the data flows into the model, and here becomes something else entirely. It becomes initial conditions, the starting point of the model's imagination. Without them, the eye cannot run. It cannot forecast from emptiness. It needs to know, where is the jet stream now? How warm is the ocean off the coast of West Africa? Is there a pressure dip over the Rockies? Are clouds thickening in the Gulf of Alaska? These questions are answered, not with guesses, but with input, observation, evidence. Only then does the machine take its breath, begin to predict. But the feeding never stops, even as the model runs, simulating 1 hour, then the next. The world keeps moving, so the sensors keep sending. The satellites keep scanning. The data never pauses, and that stream of new observations allows for something beautiful. Update. The AI watches how its forecast compares to new reality, okay? And if it begins to stray, if the real world veers away from the imagined, it adjusts. It doesn't panic. It learns. The forecast is reinitialized. The prediction bends slightly to match what's unfolding. This is called data assimilation, a kind of course correction, okay? Baked into the model's DNA. You see, no matter how smart the algorithm, it will always need the world it cannot see. The storm unless it's told the cloud is forming. It cannot predict the temperature unless it knows the wind has shifted. The machine cannot be wise without being fed, and it cannot be accurate unless it listens constantly. This is why data is not just useful, it is sacred. It's the lifeblood of the forecast, the eyes, ears, and fingertips of the AI mind. And the better the data, the better the model. It is the rule, which is why the world invests in sensors, why satellites are launched with such care, why ships at sea pause to drop measuring tools into the depths, why remote weather stations chirp in the cold of night, because the forecast begins at the moment of attention. If we stop observing, the future fades. There's something poetic in that. Just as your body needs sleep, nutrition, stillness, rest, as your mind needs books, conversation, reflection, the forecasting machine needs input, steady, rich, real, not to dominate the world, but to understand it. And the better it understands, the more gently it can speak. There is one more layer to feeding the machine. Context. It's not enough to know it's raining. The AI must know where, when, and how that compares to what came before. Was it raining more than usual? Earlier? Later? Was the storm in a typical place? Or has the pattern shifted? This is where long-term data sets come in. Decades of weather archives, recorded by human hands, by paper logs, by early computers. These old records are digitized, categorized, stored in databanks. The AI studies these archives the way a scholar might study old poetry. It finds rhythm, seasonality, recurrence, and then, when a new pattern emerges, a heat wave in March or a tropical storm in an unusual place, the model can say, this is not normal. That phrase, not normal, is one of the most important things a forecast can say, because that's when preparation matters most, when old habits no longer apply, when weather becomes something unfamiliar. And so the feeding continues. Case, past, and present, layered together. Satellite loops paired with 1930s temperature logs. Modern radar synced with hand-drawn storm maps from a century ago. This mixture of the old and new, of dusty journals and digital streams, creates depth. The forecast is not shallow. It is ancient and immediate, woven together, and through it all, the A learns to recognize the real. There is comfort in this, knowing that somewhere as you sleep, a balloon is rising, a buoy is bobbing, a satellite is blinking, and a machine is listening. You may not hear them, but they are feeding the machine that feeds you, with clarity, with warning, with peace of mind. And this is where trust begins, because every forecast you read is rooted in that quiet, endless work. The world, observing itself, the atmosphere, telling its story, and the machine, patient and curious, waiting to learn more, to learn more. The wind howls and then goes still. Clouds build into towers, then vanish. Lightning forks across a sky that was peaceful moments before. To the casual eye, the weather seems erratic, a theater of chance. But if you watch longer, patiently, quietly, you begin to notice something else. A rhythm. It's not constant, but recurring. It's not perfect, but persistent. There are shapes the atmosphere loves to make. Spirals, waves, bands, patterns, repeat across space and time. The ancient sailors knew this in their bones. The red sky in the morning, the sudden calm before a storm. The shepherd who sensed snow from silence. They didn't know the equations, but they knew the feeling. Now we build machines to see these shapes more clearly, to capture the elegance hidden inside the chaos. And this is the heart of AI in weather. It's not just to track what's happening, but to recognize what usually happens when the sky behaves this way. Because the sky does not behave randomly. It behaves in layers. Some layers move fast. The wind, the clouds. Some move slow. Ocean temperatures. Seasonal pressure systems. Some shift over decades, like El Niño or the jet stream's northern dance. And these layers interact, like gears in a giant invisible clock. Sometimes the gears align, and the weather snaps into place, like puzzle pieces. Other times, one cog slips. Pressure dip deep in the South Pacific shifts rainfall in East Africa. A warm patch of sea in the Atlantic stirs hurricane season into motion. These are not accidents. They are signals, patterns that stretch and ripple. But here's the challenge. Most of these signals are buried. They are not obvious. They are tangled in noise. They shift, morph, vanish, then return with new faces. To see them requires something more than human memory. It requires patient observation on a scale no mind can manage. Enter the machine.ai models don't look at weather the way we do. They don't see rain and sunshine. They see fields of numbers, pressure values, humidity levels, gradient flows. They read these numbers not linearly, but spatially, as patterns across maps, as curves through time. Imagine you're looking at 30 years of daily cloud cover across the Pacific. To the human eye, it's overwhelming. To an AI, it's a canvas. And on that canvas, shapes begin to emerge. Clusters, loops, recurrences. The machine begins to learn what the sky tends to do. It notices that certain combinations of variables often lead to certain outcomes. This is not fortune-telling. It is statistics, trained by nature. But what makes AI powerful is not just its ability to find patterns. It's how it finds patterns we never would have noticed in meteorology. This is called teleconnection, when distant parts of the globe influence one another's weather. A heat wave in India may be connected to a pressure dip near Greenland. A storm off the Chilean coast might whisper to the rainfall over Indonesia. The AI doesn't need to understand. Why? Not in the way a scientist might. It just needs to see that when one thing happens, another often follows. This allows the model to see farther, not just a few hours, but days, even weeks into the future. It sees not with certainty, but with context. It says, this pattern looks like one from 8 years ago, and here's what happened next. It doesn't promise that outcome, but it offers it as one thread among many, and slowly, a picture forms. This is where chaos begins to soften, because chaos, in scientific terms, doesn't mean randomness. It means sensitive dependence on initial conditions. Tiny changes at the start lead to huge differences later. A butterfly in Brazil, a thunderstorm in Texas, the classic metaphor. But even in that sensitivity, patterns can exist. The AI models run ensembles, groups of slightly different simulations, to see how outcomes spread. Some diverge wildly, some cluster tightly. When they cluster, the model gains confidence. The pattern is holding. When they scatter, the model humbles itself. The pattern is breaking. This awareness of chaos and its boundaries is what makes AI useful. It doesn't pretend to control the storm. It watches the storm unfold across thousands of possible skies. And it learns which paths the storm tends to favor. From that, it builds a map. It's not a perfect one, but a guide. This is called predictive structure, the subtle organization inside. The turbulence is like walking through a forest and realizing the trees form natural clearings. Not random, not rigid, just inclined. And once you see the clearing, you can walk toward it. This is how AI forecasts move from short-term to medium range, by recognizing not just individual events, but the structure that allows those events to emerge. You can think of it like music. Storm is a single note. A cold front is a chord. An El Niño is a key signature, shaping the tone of the entire song. AI listens to the music of the atmosphere, and it begins to hum along. This hum is what makes modern forecasting so much more precise than before. Not just because the machines are faster, because they see differently. They see relationships across variables, across time. They build latent spaces, abstract maps that organize weather into shapes and transitions. In those spaces, storms are not chaotic blips. They are movements along a path, and this path can be traced, sometimes even steered, for emergency planning. This means more lead time. For agriculture, it means better planting cycles. For travel, for energy, for infrastructure, it means fewer surprises. But perhaps most importantly, it changes how we feel about the sky, because when you begin to see the pattern, even faintly, even imperfectly, the fear softens. You understand the storm not as an enemy, but as a rhythm, a pulse in a larger system, a breath in a longer song. And here's the most beautiful part. The patterns evolve as climate shifts, as oceans warm, as land use changes, new patterns emerge, and AI adapts. It doesn't cling to old memories. It updates, it retrains. It says, the song has changed. Let me listen again. Flexibility is what makes AI uniquely suited to our time, because we are in a moment of transformation. The old, normal, is dissolving. The new is still undefined, and in that fog, we need eyes that don't tire, ears that don't forget, minds that can hold 10,000 outcomes and still find the melody. You have one right now, humming quietly in your pocket. A weather app, a forecast signal built from patterns in the chaos, and while you sleep, the machine keeps learning. It watches new clouds form, remembers an old typhoon's path. It compares, it adjusts, it prepares, and when you wake, it offers you a thought, a chance of rain, a warm front rising. A reminder that the sky, though vast, is not unreadable. It just requires patience and a little trust. The sky is always changing. You look up, and what was there a moment ago? A thin silver trail, a whisper of cloud has shifted, grown, or vanished altogether. The air moves in ways too subtle for your eyes. By the time you've noticed, the wind, it has already passed through. For centuries, forecasting meant looking ahead. A farmer might study the horizon, guess at rain by the weight of air. A sailor might taste the salt in the breeze, feel the stillness before a squall. These were gestures of intuition, broad strokes over uncertain canvas. Now, we live in an age of seconds. Your phone buzzes with minute-by-minute weather updates. A sudden downpour appears on a radar image like a digital ghost, sweeping across your neighborhood. And as you watch the animated loop, you're not just seeing where the rain has been, you're watching it arrive in near real time. This is nowcasting, a word that sounds simple but represents a quiet revolution. It means forecasting, not for tomorrow or even tonight, but for the next hour, the next 10 minutes. The moment. Just beyond this one, nowcasting listens to the heartbeat of the atmosphere. It doesn't guess, it senses. Through satellites, radar, ground sensors, and high-resolution AI models. It perceives the trembling edge of what's coming, the smallest thunderhead, the earliest wind shear, the tiniest swirl of pressure, born far away and approaching fast. And, in this instant world, those small things matter. A plane's safe landing depends on avoiding winds here in the final seconds. A cyclist checks for storm cells before setting out into the hills. A school closes early, not for a storm already raging, but for one just beginning to whisper across the plain. The gift of nowcasting is awareness. It's not dramatic, not loud. It doesn't thunder like a weather warning blaring across screens. It hums in the background, a quiet watcher of patterns, a patient student of the present. To build a nowcast, machines must pay attention to everything. Imagine a digital observer scanning every cloud, every gust of wind, every shift in barometric pressure, from the clouds above the Himalayas to the humidity hanging above your street. It all flows in data, data, and more data. But this isn't noise, not to AI. It is signal. It is story. It is the pulse of the sky. Deep learning systems, trained on years of cloud behavior, now interpret satellite images like faces. They recognize the arch of a storm front, the spiraling beginnings of a cyclone, the scattered freckles of convection. They see the subtle color changes that hint at rising air or descending cold. They hear the sky through vision, and they remember. Every misstep, every storm missed, every false alarm becomes part of their memory. Like the human forecaster who might move on, the machine holds the mistake in digital stone. It refines, it adjusts, it improves. This is not the forecasting of broad regions. Day, it is hyperlocal, sometimes street by street. It's not only that rain might fall in your city, but that it may arrive at your bus stop at 4:07 p.m. The system doesn't just suggest, it specifies. Still, it admits the truth of uncertainty, because the sky will always surprise us. A small hill can split a storm in two. A warm parking lot can birth a rising column of air that was never in the model. Chaos still hums inside. The beauty, so now casting, remains humble. It offers likelihood, not law. It helps you prepare, but never pretends to know everything. Even machines, with all their memory and math, bow to the sky, but they also learn. In this, learning matters. Think of a festival planner choosing whether to cancel an outdoor concert. In the past, they might rely on a morning forecast and cross their fingers. Now, they can see updates every 15 minutes, refining their view of an approaching weather front. A clear window might appear unexpected, but just long enough. The show goes on. Think of a city bus driver rerouting just before hail begins to fall, or a runner avoiding a sudden storm cell that blooms in the heat of early evening. These are not miracles. They are decisions made possible by proximity, by seeing the present unfold in high definition. And this is where nowcasting begins to resemble intuition. It doesn't always calculate with precision. It feels in its own way. It's like the sailor reading the sea. The machine reads the patterns of pressure, moisture, and motion. It has been taught not just to compute, but to sense. You might wonder, how? Through convolutional neural networks, digital minds, built to recognize spatial patterns. They take in layers of weather imagery, like a painter adding texture to canvas. From the base layer of temperature to the wisps of cloud edge, they see what our eyes miss. And from this, they predict what will emerge. But they are not gods. They are assistants, whispers in your pocket, hints in your dashboard, and in their best moments, remind you that the future is not far away. It is just a few breaths from now. Nowcasting also transforms how we respond to crisis. When floods sweep through valleys or snow begins to blanket roads, minute-by-minute awareness can mean the difference between readiness and regret. Emergency managers don't wait for morning models. They use nowcasts to act dynamically, locally, fast, and in return, they feed the system. Each new sensor installed, each update to satellite resolution, each weather station placed in a rural gap. All of it gives the model more to learn from. There is a kindness to this, cooperation between human and machine. We teach the model what we know, and it shows us what we could not have seen alone. And somewhere in the middle of all this, you, standing at your window, watching the clouds drift, noticing how the wind bends the tops of trees, wondering whether to bring an umbrella now. You don't just guess, you check. The forecast doesn't tell you whether it might rain in the evening. It tells you, yes, at 6:42 p.m. for 12 minutes. With winds shifting northwest, and still, it might be wrong. Still, the rain might wait, or come early. But even then, you knew it might. This is the paradox of nowcasting. More knowledge and more comfort with uncertainty. It brings you closer to the truth of the atmosphere, that it is alive, not programmable, but legible, if only for a moment. And when the moment passes, so does the prediction. So you check again and again, not obsessively, but attentively, because in watching the weather, you learn to watch the world, to tune into rhythm, to notice detail, to be present with the now. And somewhere, while you sleep, the machines continue watching. Trace the cloud lines. They whisper to one another. They predict the near future, quietly, so that your world may be just a little more known, a little safer, a little clearer, a little more yours. And just beyond the edge of this minute, they begin learning again from your street corner, from your sky. Because when machines learn to live inside the moment, they also learn something of time itself. And what does it mean when a machine begins to feel the wind? The wind is never still, not truly. Even on calm days, it stirs gently in unseen currents, over rooftops, between grasses, under cloud bellies far above. It whispers in layers, warm breezes above cold ones, slow flows around distant pressure systems. To forecast the wind is to listen for something that never holds still, that never fully reveals itself. For decades, we watched this movement from the outside. Satellites snapped pictures, radars mapped speeds, meteorologists scribbled circles and arrows. But now, machines are learning to recognize the wind, not just its movement, but its mood. They are learning to notice, to remember, to anticipate. This is the quiet revolution of deep learning, a branch of artificial intelligence inspired, in part, by the brain itself. You might imagine a neural network like a web of thought threads that strengthen with experience, not too unlike your own mind when it begins to learn a pattern. The first time you see lightning, you flinch. The second time, you wait for thunder. The third time, you sense the smell of ozone and feel the pressure shift before the flash even comes. Neural networks build similar associations, not through emotion, but through repetition. Not through feeling, but through form. They begin, often, with images, whether satellite loops that show clouds roiling like cream in coffee. A network is shown thousands of sequences. A tropical cyclone forming off the coast, a thunderstorm blooming over farmland, snowfront creeping along mountain ridges. At first, the machine sees only pixels, but soon it begins to notice it begins to distinguish not just white from gray, but spirals from stacks, motion from stillness, patterns from noise, and slowly, almost imperceptibly, it learns that certain textures of cloud, fleecy and sharp at the edges, often mean hail. That thin, high cirrus often precedes a drop in pressure. That warm oceans and wind shear and low vertical pressure form a cocktail that, over time, often spells hurricane dot. But what makes this deep learning so different from traditional programming is not the data alone, it's what the model teaches itself. No one tells it directly what a thunderstorm looks like. No one hard-code storm equals dark cloud plus wind plus drop in pressure. Instead, it studies, it digests, it begins to infer. Imagine watching thousands of people walk by. You're never told who is happy or sad, but slowly, through smiles, slumps, it's the angle of their shoulders or the tilt of their heads, you begin to sense it. That's how deep learning sees the weather. And because it doesn't rely on rules, it can sometimes see what humans miss. It can detect the subtle curl in a cloud band. That means a low pressure system will deepen. Can notice when an anomaly repeats often enough to become a pattern. And it can flag the outlier, the rare storm that doesn't look dangerous until it is. But like all students, these networks need guidance. They need feedback. Okay? They need mistakes. Sometimes the model is wrong. It predicts rain where there is none. It misses a flash flood. But each error is a lesson woven back into the network, adjusting the strengths of its connections, tuning its inner logic. You, too, have learned like this. Not from being perfect, but from falling forward, one misstep at a time. The most powerful weather models today, like Google's GraphCast or Microsoft's Climax, rely on these deep networks. They don't just ingest snapshots of the atmosphere, learn motion. They anticipate sequence. They take today's sky and play it forward, hour by hour, based on everything they've seen before, and because they're trained on decades of quantitative data, they learn to distinguish between normal variability and unusual behavior. They learn what a normal summer looks like and what a brewing heat wave looks like beneath it. They learn to spot the seeds of anomaly, and yet they are still limited. They don't feel humidity on their skin. They don't flinch at the first drop of rain. They don't hear the wind outside your window shift pitch just slightly, as you do. But they learn from us, from the sensors we've built, from the eyes we've placed in orbit, from the data we feed them constantly, endlessly, a global nervous system powered by satellites and Doppler radars and balloon sensors and microwave imagers, all of it funneling into a machine that watches the sky without blinking. And still, it's not magic. It's math, but a kind of living math, one that doesn't just describe the world, it adapts to it. In Japan, deep learning models are used to predict sudden downpours, bursts of rain that fall in minutes, flooding streets with barely a warning. Okay. In the United States, neural networks help forecast wildfires, tracking dry wind and brittle soil and temperature spikes. Okay. In Bangladesh, deep learning AI helps issue earlier flood warnings to save lives during monsoon season. And while these models aren't flawless, they are improving faster than we imagined. Some models can now outperform traditional physics-based simulations, not in every case, but often enough to shift the conversation, because they don't just predict, they learn how to predict better. There is something deeply poetic in this. Machines that do not feel the weather, learning to know it more deeply than we do. Models that never see the sun, learning to trace its effects across oceans. Code that cannot get wet, learning to understand rain. You lie in bed, perhaps now, with the air cooling softly around you. Somewhere, a machine is watching satellite loops from 10,000 miles above the earth. It is noticing a curl in the cloud. It is calculating the odds of rain in 2 days. It is humming through petabytes of data, recognizing a storm that hasn't yet been born, not feeling it, but learning its shape. And perhaps in that hum of code, there is something strangely human, a desire to see ahead, a longing to understand the unpredictable, a reaching toward tomorrow, even if tomorrow arrives with clouds, because even machines, it seems, have begun to trace the outlines of change, not by knowing emotion, but by learning the patterns emotion often follows. A heat wave begins with a quiet rise. A flood begins with a warm ocean current. A drought begins with a shift too small for eyes, but not too small for memory. And so the machines remember. And from that memory, they predict. And somewhere in that prediction is preparation. But the storm doesn't always arrive. The model isn't always right. And when it fails, what happens next? It's the next chapter. It starts with warmth. Not the obvious kind, not the sun on your skin or a humid afternoon, but warmth in the ocean, soft, wide, invisible. A bathwater temperature that spreads across the surface of the sea, slow and unnoticed. This is where the storm begins, not in thunder, not in lightning, but in a silence too vast for human senses. You could float on that ocean and feel nothing unusual. The sky might be clear, the waves gentle, but deep beneath that surface, the water is holding something. Energy. Warm water feeds the sky, okay? And when the air above it begins to rise, slowly, lazily, it takes that warmth with it. The air expands, it cools, and the moisture condenses into clouds. Tiny at first, then more, a cluster, and suddenly, what was once just warmth becomes motion. It's a flicker of organization in the chaos of atmosphere. This is how hurricanes begin, with a whisper, a curl, a gesture of wind barely visible unless you're looking closely. Humans used to see these only once they had grown. Once the clouds had thickened, the winds had formed a center, and the waves had turned violent. But now, machines see earlier. Artificial intelligence, trained on thousands of storms, can notice that early cluster, that slight spiral, that tiny depression in pressure, even if the sky still looks calm, because it has learned the storm before the storm. It knows what storms looked like. Hours before they earned a name. It remembers the shape of beginnings, and so it watches. Patiently, quietly, the model runs in. The background is feeding on satellite data, wind speeds, sea surface temperature, vertical shear. Each input, a pixel in a larger painting, and then a shift, a signal. Not dramatic, it's just enough, an anomaly, small but familiar. A warmth, a wind, a wobble. And so the AI flags it, not as a warning, not yet, but as a whisper, a possibility, a name still unborn. This early detection matters, because tropical cyclones, once formed, feed on themselves. The rising air lowers pressure. Low pressure pulls in more air. More air brings more moisture. And more moisture brings more energy. It becomes a loop. Self-sustaining, self-intensifying, but only if given time. If caught early, if watched closely, there is a window, a chance to prepare, to warn, to act. And this is where AI becomes more than prediction. It becomes prevention. In Bangladesh, early detection has saved thousands of lives. Storm shelters, air opened in time. Coastal evacuations are planned days ahead, not hours. Fishing boats are recalled before they leave harbor in the Caribbean. KI forecasts now refine storm paths, shaving uncertainty from the map. Not perfectly, but better. Enough to decide whether to shutter windows or evacuate an island. And still, the storm grows. Maybe not, because not all whispers become roars. Some clusters fizzle, some spirals break apart. Some warmth is not enough, but the model watches them all and learns from the storms that came and from the ones that didn't. That's part of the lesson. Knowing when the storm won't arrive is as valuable as knowing when it will. There's peace in clarity, even if the forecast says calm, especially then, because anxiety grows in uncertainty, in not knowing. And AI, though not perfect, trims the edge off that unknown. And when the storm does come, it no longer arrives alone. It comes with maps, with paths, wind speed probabilities, and surge predictions. It comes with a story already written in models and shared with the world. And that story began days before, in the soft warmth of a quiet ocean. In the first flicker of cloud dot, the storm before the storm. You may never see that part. It's not in the headlines, not in the footage, not in the alerts, but the machine saw it. It watched as the ingredients gathered. It traced the motion that would become momentum, and it remembered the hundreds of storms that began just this way. And as it saw, it learned. It noted how this spiral was slightly different, how the wind shear was gentler, how the ocean heat was deeper. And it adjusted, not once, but constantly. Every hour, the model changed its mind, sharpened its prediction, updated its map. You might call that uncertainty, but it's really attention, adaptation, a willingness to evolve. You've done this too. It sensed something small, a look, a pause, a sentence left unfinished. You felt the beginning of something still far away, and you prepared, not out of fear, but out of care. That's all the machine is doing, caring, in its own way, about patterns, about people, about possibility. The storm doesn't scare it. It simply watches, listens, learns, and through that learning, it helps us do the same, to see more clearly, to act more wisely, to live more gently, even in the face of chaos, because chaos has patterns. And patterns, once known, become maps, and maps make space for choice. So as the wind rises, as the pressure drops, as the clouds thicken, we are not surprised. We are ready, and readiness is its own kind of calm. But storms don't only come from oceans, They don't only spin with names and satellite images. Some rise in silence, from land, from still air, from strange humidity and awkward heat. And A is learning those too. It's learning to watch clouds, to read them, not as pictures, but as signals. And in those signals lies the next chapter. You've watched clouds before, maybe from a car window, eyes soft with thought, maybe from a hilltop, lying in the grass. You've given them names: rabbit, castle, dragon, ship, soft silhouettes painted across a shifting sky. But clouds speak a language deeper than their shapes. They are the breathing patterns of the earth. Each form a signal, each edge a boundary between what was and what is becoming. And now machines are learning to read this language, not with poetry, but with code. They don't see rabbits or ships. They see water vapor densities, infrared temperatures, updraft, velocities, ice crystal scattering. But somehow, the machine's way of seeing brings us closer to understanding, because clouds are not decoration. They are behavior. They show us what the atmosphere is doing right now, and what it might do next. A low, flat, straightest cloud, stretched like fog across the horizon, tells a different story than a rising tower of CUMULONIMBUS.1 suggests calm, other, thunder, lightning, maybe even hail. And yet, to an untrained eye, both might just be cloudy skies. This is where artificial intelligence becomes a guide. It takes satellite images, frames in an endless movie, and stitches them into motion. But, more than that, it learns to recognize. It doesn't just see a cloud. It remembers the thousands of clouds before it. The ones that brought rain, the ones that meant nothing, the ones that began as harmless fluff and ended as tornadoes. It maps patterns. It studies color gradients, shapes, motion vectors. It learns the difference between growth and anticipation between a cloud that's thinking about becoming a storm and one that's simply passing by. Think of it like facial recognition for the sky, a neural network trained not on people, but on patterns of moisture. Over time, it becomes fluent, not perfect, but fluent enough to say, this cloud has the same birthmarks as a supercell from 2012, but these upper-level winds resemble conditions seen before derecho. It's not guessing, it's remembering and comparing. But not all clouds shout. Some whisper, tie, thin cirrus, veils of ice, miles above your head, can signal a coming front, a distant storm, shifting jet stream. At AI notices their curvature, their speed, their trailing fibers. It cross-references that with pressure data, wind, shear, humidity, and then, quietly, it updates the forecast. It's not dramatic. There's no warning bell. It's just a soft recalibration dot, like changing your course by 1 degree. It's that 300 miles later, you missed the mountain entirely. In this way, code becomes a kind of cloud watcher, a digital shepherd of vapor and wind, and in doing so, it restores something very old, because long before satellites, before radar, before Doppler scans and weather balloons, humans watched clouds, sailors, farmers, monks. They knew the sky. They read it not with data, but with intuition, experience, passed down in whispers. Mackerel, sky, not long dry. Red sky at night, sailor's delight. These were the proverbs of survival, the poetry of weather. And now machines are bringing back that kind of watchfulness, but scaling it to a global mind. A single AI can watch every cloud on Earth, all at once. Every 10 minutes, it knows what's forming over the Amazon, what's dissolving over the Gobi, what's spinning off the coast of Japan, and still, it notices the little things like a strange curl in a cloud deck, a hole punch in a field of altocumulus, a filament of smoke interacting with fog. It doesn't understand them the way we do, not yet, but it sees them and it remembers. That memory is powerful because sometimes clouds repeat themselves, not exactly, but closely, and in that repetition, K finds rhythm. Storms are never the same, but they rhyme, and by listening to that rhyme, we forecast the verse that might come next. This is why cloud recognition matters. It's not just about seeing, it's about learning how the sky thinks, because every weather event begins in the clouds, and every cloud begins with a conversation between air and heat, water and motion. You don't always hear it, but it's happening, and now there is a listener that never sleeps, never blinks, never stops watching. This is more than prediction, it's participation. AI doesn't control the weather, but it joins the dance, keeps time with the rhythm, and whispers its findings into human ears, to pilots, to farmers, to rescue teams, to anyone who needs to know whether the sky will turn, and what once took hours to decode, to project, to share, now takes seconds. The moment a satellite sees a cloud, the machine sees it too, not just what it looks like, but what it means. And then, quietly, it adds that meaning to the forecast. It's strange, isn't it, that something so soft, so shapeless, can carry so much weight. A cloud looks like nothing, but it is memory, physics, breath, warning, and story all at once. The machine sees that now, not the way we do, not with feeling, but with function. And yet, even in that function, there is beauty, because knowing is its own kind of wonder. And watching the sky, truly watching, is an act of love. It says, I care what happens next. I'm paying attention. And so, the code pays attention. And because it does, we can too. We can walk outside and look up and know that somewhere, a machine has also seen what we see, and maybe, just maybe, it saw it a little more clearly. Still, clouds don't always lead to storms. Sometimes they vanish. Sometimes they signal peace, and even peace must be learned just as much as chaos, Because when the forecast goes wrong, when a storm fails to form, or arrives early, or acts in a way no model predicted, the cloud still holds the answer. But only if someone's willing to admit, we didn't know yet. And from that humility comes the next chapter. You wake to rain you weren't expecting. The forecast had said clear skies. But now, soft drops tap the window like polite reminders. The app was wrong. The prediction failed. Still, the rain falls exactly as it must. This is the truth of weather. It does not obey. It does not always reveal itself, even to the best eyes or deepest code. Even machines, for all their precision, their patterns, their speed, can still miss what's coming. Sometimes, a small pressure pocket forms in just the right patch of atmosphere at just the right moment. It wasn't there an hour ago. It didn't follow the usual script. But now, it spirals, gathering moisture, breathing wind, writing its own quiet story. No model caught it. No forecast showed it. In the sky. Changed anyway. Failure in this world isn't dramatic. It isn't thunderous or defiant. It's simply a missed note, a harmony unplayed, an edge not traced closely enough. And yet, failure is part of how the model learns, because every wrong prediction is also data. A lesson folded back into the neural net. A reminder, there is still more to understand. Imagine this. An AI model had predicted that a thunderstorm would skirt a city, passing 30 miles north. But instead, it bends, takes a sharper turn, sweeps through the urban center, drenches streets, halts traffic, rattles windows. Emergency alerts had not been issued in time. People had trusted the map. Later, the machine studies this miss. It's fed the radar footage, the wind readings, the satellite loops. It retraces its steps. Where did the error begin? It's the pressure gradient, just slightly too shallow in its input. Did it misjudge the speed of an upper atmospheric current? Was a local terrain feature, a hill, a body of water, left underweighted? And, most importantly, how should it adjust next time? This is called post-processing. The machine is not scolded. It is not punished. It is corrected, gently, carefully. Each failure softens the edges of certainty, and that softening is what creates strength, because in weather, rigidity breaks. Only flexibility adapts, and that's the miracle of modern models. Bend. They admit when they were wrong, and in doing so, they get better. Unlike older forecasting systems, which were hard-coded, rule-bound AI models evolve, not on their own, but with help. Teams of meteorologists and data scientists guide these corrections like teachers. They don't just say, that was wrong. They ask, why? It a rare anomaly, a once-in-a-decade pattern, or was it a blind spot, something the model is still too young to see? In this way, each failure becomes a tiny window, not into the atmosphere, but into the machine's mind. And that mind, though artificial, is slowly learning humility, because it's not enough to predict. You must learn from what the world actually means. DOESTHATs, the difference between knowledge and wisdom. Forecasting, you realize, is not about being right. It's about being ready. And readiness comes from the willingness to adapt. Sometimes, the model had the data. It just didn't give it enough weight. It underestimated the sea temperature, or ignored the soil moisture, or didn't fully understand how snowpack in the Rockies might shape air currents states away. There are always factors just beyond its reach, because the atmosphere is not a chessboard. It is fluid, layered, emotional, almost. It remembers the day before. It responds to shadows, to smoke, to heat rising off asphalt, to millions of tiny variables that no sensor can fully capture. And so, the model learns in hindsight. But that hindsight is golden, because next time, when it sees a similar formation, a similar curve in the wind, similar quiet before the shift, It will whisper a different future, and that whisper may be what helps someone change course, cancel a flight, cover a crop, postpone a game, stay home. Sometimes, just a few hours warning makes all the difference. So failure is not defeat. It is refinement. It is refinement. Imagine if you could treat your own mistakes this way. Not as shame, but as signal. Not as flaw, but as feedback. Forecasts fail, and the sky teaches the model how to fail better, how to rebalance, how to add nuance, how to soften its confidence, and widen its perspective. You can do that too, because failure doesn't always mean you didn't understand. Sometimes it means the system changed, the context shifted, okay? The old pattern dissolved, and that's okay. The question isn't, why didn't I see that coming? Kids, what did I just learn that I couldn't have known before? The atmosphere forgives. It keeps moving. So does the machine. So should you. And maybe this is the beauty of AI in weather. It's not perfect, but it's willing to improve, to be wrong today, so it can be a little more right tomorrow. In all of this, it's quiet conversation between clouds and code, between error and learning. It's all in service of something very human, because at the end of the day, weather affects you, your walk, your home, your mood, your sense of safety, and the machine's job is not to dominate the sky, but to help you meet it with understanding. So when the forecast fails, pause, watch, listen. What changed? What was missed? What was missed? And what might you carry forward from it? Because the next prediction is being built from the last mistake. And that's how storms teach silence, how failure teaches insight, and how the unknowable becomes slowly known. You step outside. The air smells of coming rain. The trees shift in a breeze that wasn't here an hour ago. Above, the clouds gather, not fast, but certainly, like a quiet decision being made far above your head. You sense something in the sky, and somewhere a machine does two dot in a distant server room where rows of processors hum like mechanical bees. Data from your sky joins billions of other data points. Pressure readings from an airport 30 miles away. Humidity from sensors on the highway. Satellite imagery from an orbital eye spinning over your continent. It all flows in, your local forecast, the app on your phone, the words scrolling on a news broadcast isn't created just from what's around you. It's built from everywhere. From glaciers melting in the north to ocean warmth stirring the Pacific. From the jet stream rolling over cities you've never seen to a dust storm halfway across the globe. Your weather isn't isolated. It's entangled, and AI knows this. Traditional weather models, the kind built on equations and physics, worked like vast engines of approximation. They divided the atmosphere into grids, three-dimensional boxes of sky and sea, and tried to predict what would happen next in each box. These models were powerful. They are still used, still crucial, but they are slow. They struggle with detail, and they don't always capture the chaos of what happens right here. AI, though, learns differently, where the old models simulate. AI remembers. It studies the past thousands of storms, millions of days of temperature swings, fogs, droughts, sudden winds. It learns how small details lead to big changes. A slight dip in pressure over a warm surface, a twist of air following a certain pattern. To AI, these are not noise. They are signals. They are the whispered beginnings of weather. And this is how the global becomes local. A deep learning model might ingest weather data from across the planet, from Doppler radar in Illinois to typhoon paths in the Pacific, and then output a forecast for your backyard. It does this not through intuition, but through pattern recognition. It has seen combinations of data like this before. It has learned what came next. What's remarkable is how this changes the very scale of weather prediction. AI doesn't just make one forecast for one place. It makes billions. It zooms in, creates hyperlocal forecasts for your street, your neighborhood, your city block. It personalizes weather not by knowing who you are, but by knowing where you are. And this matters, because weather is not evenly distributed. So rain might fall on one side of town and not the other. Fog might settle in a valley, but leave the nearby hills clear. A gust of wind might spiral along one road and vanish before the next. These tiny differences used to be invisible to forecasters, but now, with enough data and enough learning, AI begins to see them. It begins to feel the local. Take, for instance, the way AI helps farmers. In places where drought can destroy a harvest or where a sudden frost can ruin a crop, having a forecast that's accurate to a single field, not just a region, can be the difference between success and failure. AI-powered weather tools now provide this kind of precision. They don't just tell you it might rain, tell you when, for how long, and how much, right down to your coordinates. Or think of emergency responders who need to know exactly where a wildfire smoke will drift, or which neighborhoods might flood in the next hour. These decisions are made in moments. And now, AI helps inform those moments, offering not just predictions, but visualizations, maps that update minute by minute, forecasts that grow more confident or uncertain in real time. And yet, its local sharpness doesn't come at the cost of the big picture. That's the brilliance of modern AI forecasting. Because while it zooms in, it never stops looking out. Some AI models are trained globally. They don't learn just from your climate or your continent. They learn from everything. Winds and Saharan heat. From mountain updrafts and equatorial storms. The model that helps predict whether it will rain in your city tonight also understands, in its own way, how monsoons breathe across South Asia or how El Niño disturbs the Pacific. This global learning allows AI to connect dots human forecasters might never link. It spots long-distance influences, like how warmth in the Gulf of Mexico might strengthen a storm forming off the East Coast, or how snowpack in the Rockies might affect spring floods hundreds of miles downstream. These are complex relationships. They don't follow straight lines, but AI is good at this kind of complexity. It doesn't need to understand causation in the way a scientist might. It only needs to know that when this happens, that often follows, and to know it with enough reliability that you can trust the outcome. This is why, in some parts of the world, AI is already outperforming traditional weather systems. In the United Kingdom, for example, the Met Office has developed AI tools that rival their supercomputers for certain forecasts and do it faster. Google's DeepMind partnered with researchers to create GraphCast, a system that uses graph neural networks to outperform many standard models. It learns from global data, but delivers local insight, and it learns fast. What used to take hours of simulation now takes seconds. Forecasts update more frequently. They adjust to real-time conditions. You no longer need to wait for the next computer run. The sky shifts, and the model shifts with it. This is not the end of traditional meteorology. Human forecasters still interpret, still guide, still check the models for reasonableness. But AI offers something new. A second set of eyes, tireless and detailed assessed, that can scan the whole planet and still notice when the wind in your backyard feels different than yesterday. Of course, this new power comes with its own questions. How do we ensure these models are fair, that they serve rural areas as well as cities? How do we make forecasts accessible, understandable, trustworthy? How do we avoid over-relying on machines and forgetting the art of human weather wisdom? The feel of the air, the smell of a storm, the creak of an old window just before it rains. Perhaps the answer is not to choose between human and machine, but to invite them both into the conversation. Let AI see the patterns too big for us. Let forecasters interpret what the machine cannot feel. Let you, the one who steps outside and notices the sky, be part of that loop. Your observations still matter. Your senses are still sensors. The future of weather is collaborative. It's local and global, precise and vast, human and artificial. It's a sky that never sleeps, watched over by eyes made of code and by hearts that still wonder what the clouds are saying. And maybe that's the most powerful forecast of all. One where every part of the system listens to every other. Where the world is not just predicted, but connected. Because in the end, your local sky is never just yours. It is touched by oceans, warmed by currents, stirred by winds that began their journey thousands of miles away. And somewhere deep inside that journey, a new signal begins to rise, not in thunder or storm, but in heat, steady change, a shifting rhythm. The climate begins to speak a new language, and AI listens, learns, adapts. But can it keep pace with a world that is rewriting its own weather? Its own weather? The climate is not a fixed stage. It breathes, it adjusts, it members, it does. And now it is changing. You can feel it in your skin sometimes, in winters that come late and linger strangely, in summers that feel unfamiliar. The sky is not broken, but it is different. The rhythms you once trusted begin to loosen. Rain comes when it shouldn't. Winds grow where they once were gentle. The quiet signals of the atmosphere now speak in unfamiliar tones. And still, you must try to understand. Weather has always been a shifting language, but climate is its grammar, the long, deep structure behind the sentences of storm and sun. For generations, humans memorized this grammar. Farmers knew when frost would fall. Fishermen could smell a storm hours before it bloomed. Seasons followed a choreography so old it sank into memory. But now the dance is changing. Can not all the old steps apply? This is where artificial intelligence becomes more than just a tool. Because AI does not need memory. It builds its own, does not compare today's weather to a childhood snow. It compares it to a century of satellite imagery, barometric pulses, oceanic cycles, and sudden storms. It sees not in nostalgia, but in signal. It listens without fatigue, and the signals are shifting. Some of the earliest signs of climate change live in data, not in hurricanes or heat waves, but in the numbers, subtle changes in rainfall timing, small deviations in pressure fields, the slow thickening of humidity over oceans that used to whisper cooler thoughts. These are not things your senses catch. They are too quiet, it's too slow. But AI hears them. It maps them. It learns their cadence. It watches them bend and stretch and reappear. It builds a new grammar for a new sky. Climate change is not a single event. It is a long conversation between Earth and time. It unfolds over decades, sometimes centuries, in the rise of carbon and methane, in the melting of glaciers that took 10,000 winters to grow. And yet, in every single day's weather, a small piece of that larger story appears to sell. The machines are learning to trace those pieces. They are trained on storms, millions of them. They learn what a hurricane looks like when it's healthy and when it's unusual. They learn the temperature of an ocean that spawns cyclones and how that temperature is rising in patterns we've never seen. They learn the fingerprints of drought, not in the crackle of dry leaves, but in the slow retreat of soil moisture and the silence of evaporated rivers. This is not just forecasting. This is remembering. Climate aware. AI does not just predict, it adapts. It adjusts its algorithms, its confidence levels, its interpretation of risk. When historical patterns break, it doesn't break with them. It evolves, finds new correlations, sees new risks. It becomes less like a mirror and more like a lens, showing you not what the world was, but what it might be becoming. And through it, you begin to see differently too. You start to notice that normal no longer means what it used to. That a heat wave in spring is not just an outlier, but maybe a preview. That wildfires aren't accidents of weather, but symptoms of a warming rhythm. that floods come from skies heavy with more vapor than the earth used to hold. The weather becomes a kind of teacher, and the lesson is that change is not coming. It's already here. Still, you do not need to fear it completely, because adaptation lives in knowledge. And AI, in its own quiet way, is helping you prepare. Cities now use AI to manage heat risk, turning down power grids before they fail, directing cooling resources to those who need them most. Forest managers model how fire might spread weeks before a spark. Hospitals use real-time forecasts to anticipate respiratory illnesses when air quality dips. Farmers, perhaps more than anyone, benefit from this intelligence planting, irrigating and harvesting with precision that honors both the soil and the sky. All of this from machines that do not feel, but they see, and what they see is not just danger, but possibility. They see how early warning can save lives, how adaptation isn't just policy, but practice, how resilience is something that can be grown, like a garden, with daily care and gentle adjustment. They show you how even in a changing world, you are not helpless. You are not without tools, but tools are not enough. The deeper question becomes, how do you respond? It is one thing to know a storm is coming. It is another to change your life. So fewer storms arrive. Here, climate-aware AI becomes a kind of mirror. It shows you what will happen if emissions continue, what the Earth's breath will sound like in 50 years, how today's choices shape tomorrow's skies. This is where science meets ethics, where data meets responsibility, and AI does not decide. You do, but it helps you see the decision more clearly. It helps you understand the costs of inaction, the benefits of renewal. It shows you where forests regrow, where carbon sinks deepen, where the air begins to lighten again. And these are not fantasies. They are models, yes, but grounded in physical law, real observation, and thousands of simulations. AI is not here to scare you. It is here to see clearly. And maybe that clarity is what matters most right now. Because even in uncertainty, there is grace, there is time, there is room for movement. The climate is not a door that is closed. It is a path that is tilted, and you are still walking it. With every step, machines walk with you, watching the wind, measuring the sea, learning what the world becomes as it warms. And somewhere in that partnership, human and machine, choice and consequence, a new balance may emerge. A balance where AI doesn't just react to change, but helps shape response, where weather forecasting becomes climate understanding, where data becomes wisdom, and perhaps hope, a soft kind, a slow kind. It's a kind that doesn't promise a perfect future, but a possible one, because even now, as temperatures rise and coastlines retreat, the sky still holds wonder, the earth still breathes, and you still have time to listen. And if you listen long enough, you may notice something stirring on the horizon, a new kind of silence, one shaped not by absence, but by learning, a silence that listens and prepares. You are falling asleep now. The room is quiet, okay? The hum of the night has settled into stillness. The air around you barely moves, but far above and far beyond, the atmosphere keeps shifting. Unseen winds tumble over oceans, clouds gather in invisible places, tiny currents spiral through canyons of cold and heat. The world is not still, even when you are, and while you rest, something watches, not with eyes, not with ears, but with sensors, with algorithms, with memories stretched across time, mind built not to feel, but to notice, to learn, to dream. This is artificial intelligence, not as you've seen it in stories, but as it quietly exists now. In the background, in the sky, it does not sleep. It listens, it models, breathes in data, and exhales prediction. And as you drift off, it begins to dream the weather ahead. This dreaming isn't made of clouds and stars. It's made of patterns, soft ripples and pressure fields, echoes of past storms. The gentle pull of a warm ocean current deep in the Pacific. The AI doesn't imagine like you do. It doesn't wonder, but it does build line by line, layer by layer, an unfolding picture of what tomorrow might hold. And this dream begins in silence. Thousands of satellite images are gathered, sensors from mountaintops, from deep-sea buoys, from airport, towers and forest clearings, all send back whispers of temperature, wind, humidity. These are the notes. The AI turns them into music, not finished music, not yet. The tune is a sketch, a possibility, a tomorrow that may bend and stretch. Before it arrives, still, it sings, and the machine listens. Neural networks, deep and wide, begin to process. They've seen so many storms before. They've learned what snow looks like before it falls, what lightning feels like before it strikes. They recognize the curved arms of hurricanes as they bloom, the shy birth of fog at dawn. These are not just images, they are signs, and signs become stories. In this dreaming, the AI tries out tomorrow in thousands of forms. It runs simulations, parallel lives of the sky. One version has morning rain, another brings clear sun. Third shows a gust that might snap a branch. Each possibility dances across its digital mind, and from these, it chooses the most likely shape of the day to come. But even this choice is not fixed. It is always open to revision. Every hour, new data arrives. The models adjust. They breathe. They correct. Forecasts grow sharper the closer they come. Like someone slowly focusing a lens as the subject approaches. You, meanwhile, sleep, unaware that while you rest, tomorrow is being rehearsed. That someone or something is already studying the wind that will greet your morning, already watching the clouds that may slide across your noonday sky, already sensing the warmth that might linger on your evening walk. There is something oddly comforting in this, the idea that you are no longer alone in trying to guess what the weather will bring, that a partner now joins you, quiet, tireless, mathematical, whispering predictions based not on superstition, but on knowledge. And yet, still something deeply human about this dreaming, because even though the machine does not feel the coolness of rain or the tension of dry thunderclouds, it becomes, in a way, your extension, a helper, a guide. Its calculations, when shared, become your decisions, jacket or no jacket, windows open or closed. Should you water the plants? It's tiny questions shaped by vast intelligence, and this intelligence does not rest while you sleep. New weather blooms elsewhere. A sandstorm curls over North Africa. A typhoon spins across the Pacific. Snow begins to dust a northern forest. These are all part of the dream now, part of the model. The earth speaks in millions of variables. No single person can hold them all, but the machine does not forget. It remembers last winter's flood. It remembers the strange heat of a February afternoon. It remembers the way wind moved through a certain mountain pass 6 years ago, and how a similar pattern appears now. Memory becomes prediction. History becomes a map of the near future. And so, the AI keeps watching. Sometimes, it warns early. Coastal storm is spotted before human eyes would have known. A flood alert is triggered in a quiet village hours before the river swells. These are the small victories of dreaming ahead. Not everyone perfect, but enough to matter. Other times, the dream is wrong. The sun shines when rain was expected. The air grows still when wind was promised. The model learns again, adjusts, updates. Even in mistake, it is listening, because the point is not perfection. It is presence. To have a presence digital, tireless, wide, that watches the sky with care, that pays attention to what you may miss, that holds the story of the atmosphere in numbers, but returns it to you in language, a forecast, a map, a warning. Oh, so when you wake, The sky may still be full of mystery, but it is a mystery someone has studied. A mystery partially translated, and with every morning, that translation grows just a little more fluent. You might check your weather app over breakfast. You might plan your day around its numbers, But behind that simple interface is a dream, one that began while you were deep in your own, one that started with whispers in the dark, and it continues now. The AI is still watching. New data flows in, clouds evolve, pressure shifts, the day opens its palm and reveals what it will or won't become. But always, the dream remains, flexible, gentle, ready, because weather is not just a forecast. It is a conversation between earth and air, between past and future, between you and the sky. And tonight, as you close your eyes again, know this: someone is already watching the winds that haven't yet begun to blow. Someone is already listening to the clouds you haven't yet seen. Someone is already dreaming the sky ahead for you, for you.